Okay, hello everyone, welcome back to my channel. So in this video, we will talk about the integration of 1 over cosine x plus 1 with respect to x. On the last video, we just talked about how to derive the power reduction formula when we integrate a tangent function and when it's raised to the power of n, where n is an arbitrary integers. So more importantly, integers that are larger than 1. So let's just start now. So first of all, we can just observe that we cannot directly integrate this function, or just like doing substitution, because when we directly substitute u as cosine x plus 1 and then we take the derivative of it, or roughly we want to say that we try to figure out what du equal to is, then we will find out that we cannot write du here when we substitute u is equal to cosine x plus 1. So that's the reason we need to do some manipulation. So again, I just remember that there is an identity equation for trigonometric functions that says sine squared of x plus cosine squared of x, no matter what the value of x is equal to 1. So in order to bring it here, then I think it is the best idea to multiply the numerator and denominator by cosine x negative 1, or maybe you can just directly multiply the both sides, upper side and the lower side, by negative 1, negative times 1 minus cosine of x. Maybe that's the good idea. Or just make it like, okay, just make it this first before doing further manipulations. And from the rule of a plus b times a minus b equals a squared minus b squared, on the denominator we will get something like this, and on the numerator or at the top we will get something like this. And a factor negative sign in the denominator, so we pull out the negative sign, we will get, so I just show you all the steps so to avoid confusion. And based on this, we will get this. Okay, since we have the same denominator here, so I think it is a good idea to split the numerator to like this. So we split the numerator and just put the negative sign inside, and we get here the integral of 1 minus cosine squared of x dx. Okay, so from here we know, so just let this becomes the first equation, or equation 1. Recall that sine squared of x plus cosine squared of x is equal to 1, regardless of the value of x. Okay, so this implies sine squared of x is equal to 1 minus cosine x squared we plug that into the equation 1, we will get really nice when we finally figured out the thing that we should do to solve this integral. Really, it's really satisfying. Yep, so here, so this is what we get here, and yeah, so for here we know that 1 over sine of x is equal to cosecant x, so we can rewrite it as, or just let me substitute, do something that we call substitute integral here, because if you look at what we have here, okay, so we have cosine x dx on the top and sine squared of x at the bottom. And I think it's a good idea when we substitute sine of x is equal to a particular variable. So let z become sine of x, then we get that dz is equal to cosine x dx. This is obvious, okay? We have it here. So we can just directly write it as, write it down again to make sure everything is clear. Oh, come on. So what happened when you see this? I just wiped my screen because there's water on it. Okay, so here we have 1 over z squared dz plus, we write that term as cosecant x squared. By power rule for this term, we get something like 1 over z plus, okay, wait, is there anything wrong here? Do you see something wrong here? No? Okay, I think so. I think there's nothing wrong here. So just like, okay. So there is a formula that states that the derivative of cotangent x is equal to negative of cosecant squared x, the negative, okay? So that means that the integral of cosecant x squared is equal to negative cotangent x. So just write that down. So we have wait a second. So what's happened with my pen here? Okay, wait. Okay, here we go. So just write that plus here. So get rid of this sign, this negative. Negative of cosecant, not cosecant, cotangent x plus c. So we can plug z back. So we have, or we ended up with cosecant, because 1 over z is equal to 1 over sine of x, and 1 over sine so 1 over sine of x is just the same as cosecant x. So here's our result. Now every time when you already obtain the result of your integral, it is the best to do a sanity check by taking the derivative of your answer. Okay, so let's see what we have. What we will get. The dx of cosine x cotangent x plus c. And you know that the derivative of cosine x is like, it's just the derivative. So we just put the derivative inside. So we have sine to the power of negative 1 x, sine x to the power of negative 1 minus the derivative of cotangent x plus the derivative of c, which is equal to 0. So we have minus sine x times minus sine x to the power of negative 2, and the derivative of x, sine x, is cosine of x, and we have here derivative of cotangent x is plus, because the derivative of cotangent x is equal to negative cosecant x squared. So we have plus cosecant x squared, which is 1 over sine x squared, or we can just write it down like this. And this 0, so just leave it here, leave it like that. And we can factorize the sign. So we end up with 1 over cosine of x. Okay. And then we know that it is equal to 1 over cosine x over 1 minus cosine of x over sine squared of x, and this is just equal to this thing. Okay, so and we have by the rule of a squared minus b squared equals a squared, not a squared, a plus b times a minus b. Sorry for the bad writing. And we know we can divide both sides by cosine of x. And here is the thing that we need to pay attention for, that in order for us to be able to divide 1 minus cosine of x here, is that 1 minus cosine of x should be not equal to 0, which means the domain of x, it should not be including 0 or any angles that will give us the result that cosine of x is equal to 1, which is 0 and then 2 pi and etc. So we cannot use angles that is the multiplication of 2 pi, where the multiplication is integer. So we cannot use 0, 2 pi here. That's the thing that we need to pay attention for. So now we assume that x is not equal to 0 or something like that, that will give us cosine of x is equal to 1, so we can divide that thing. So we end up with this. So we already proved that our result is correct, or in other words, our integral is correct, indeed correct. Wait, I make a mistake here. It should be duplicate instead of copying. Okay, here we go. Not that. Yeah, it should be here. So we have Yeah, nice. So we will end up to our starting point again if we take the derivative or our answer here. See, if we take the derivative of this, we will directly go back to our starting point, which is 1 over cosine of x plus 1. So we already verified our answer, so we can say that this answer is true. And we need to pay attention that we are doing indefinite integral here, so we need to add plus c because we don't know exactly the exact function, the exact function which becomes the antiderivative of this. So again, based on the definition of indefinite integral, that the result is the family of function. So the family of function means that these functions are differ by the constant. Okay, so that's our result here. So thanks for watching. I hope this video can be helpful for you to solve integral something like this. So here we are applying some algebraic manipulations. We were also using trigonometric identities equations, and also using substitution technique to solve the integral. So I hope you guys enjoy this video and consider subscribe this channel, and don't forget to like, comment, and also hit that bell button so you can get the newest notification from my channel. So thank you for watching and have a nice reading week, because this video is recorded on February 17th 2023 at UTM. Okay, have a nice reading week.